Okay, if you're joining us from home, please pause the video for a couple minutes and copy down the network and finish the problem from yesterday's lesson, which was angle addition. All right, so let's see what happens here. I've got the measure of angle JIL. So JIL, back up a little bit, JIL is this angle right here, and that is 20x minus 10. And then I have the measure of angle LIK. LIK is 8x minus 20. And then the measure of the big angle is 140 minus 6x. So you should have set up your equation as this angle plus this angle equals the big angle. The two little angles added together equal the big angle. So in my like terms, I have 20x and 8x. That's 28x. And then negative 10 here and negative 20, which is here, is negative 30 equals 140 minus 6x. Subtracting 6x is going to give me 22x. And adding 30 to both sides is going to give me 170. When I divide by 22, I get x equals 5. Then I can go back and plug them in to each equation and come up with my individual angle measures. So if 3 times 5 minus 10 is 90. So angle JIL is 90. And 8 times 5 minus 20, so 40 minus 20, so angle LIK is 20. And then 140 minus 6 times 5 is 30, gives me 110. Take a moment, pause the video, copy down your table of contents and your objective for your next notebook page. Okay, segment bisector, new vocabulary. We're going to be seeing this word a lot throughout this semester, and it will be on your final exam, so we need to understand what it is. So take a moment to pause the video and copy the definition in your notes. All right, so go more into the word bisect. We're going to break it into 2 sections, or 2 syllables, I guess. It's a compound word. The first part of the word bi means 2, like bicycle, 2 wheels, bilingual, speaks 2 languages, bi-monthly. You might get a job someday where they give you bi-monthly paychecks instead of bi-weekly paychecks. Okay, so different. All right, and then sect means to cut or sever. So section, I can divide my room into 4 sections. Bisect, in biology, you may have dissected a frog, which means that you kind of do surgery on it, you cut it open. And sector, you see that word more in government, where they divide counties or states into different sectors. All right, so let's move on. Okay, bisector is a noun. Okay, so line right here is a bisector. It is a segment bisector. So in that case, it's a noun. If the line is bisecting the blue line, then it's a verb. Okay, so you're going to see it in both contexts. So make sure you understand the difference between the 2. All right, the difference between segment and bisector. Go ahead and take a minute and pause the video to copy down those notes. All right, so the main difference between a midpoint and a segment bisector is that if I have some line segment AB here, I have, let's call it a line. Some random line is coming down from outer space and it's going through line AB at the exact middle of the line. So it's cutting the line in half, and in doing so, it's actually creating the midpoint. Okay? A segment bisector creates the midpoint by a line segment. All right, and we also had a discussion today about this. Can I bisect a line? Can I bisect, let's call line L the bisector and line M the line that's being bisected. So so this guy is bisecting the red line. Can I bisect a line? Think about it for a second. Let's say, maybe I should do this with a midpoint example. That might be better. Can I find the midpoint of the line? Okay, so let's say I'm going to call this the midpoint of line M. Okay, well, it kind of looks like it might be the midpoint, but if you'll notice, the line goes forever in both directions, so this keeps going. It's not like the midpoint anymore. If it goes on, I cannot take the midpoint. I cannot find the midpoint. The same is going to be true for array. Okay, I cannot find the midpoint of array because the ray goes forever in one direction, so you will never be able to find the midpoint. So you can only find the midpoint in segment, and you can only have a segment bisector of a line segment. It doesn't work when these are lines, when A would be a line. All right, first example, line L is a segment bisector of AB, line segment AB. So if line L is a segment bisector, notice these markings here. That means that AM and MB are congruent because the line is being the segment is being bisected, which means this has to be equal to this. So take a minute, pause your notes, and write down the problem. All right, example 2, line AB, the language up here. So line AB, line segment X at point Y. So AB is doing the bisecting and XZ is being bisected. So this is the thing that's being bisected. Okay, cut in half. Then it says find X and find the length of X. These two segments are equal. That means that this has to be equal to this. So that's it up. I'm going to go ahead and distribute now. 2x plus 8 equals 3x minus 3. And then when I do the math, I end up with x equals 11. All right, so go through your work. I'd like to see the steps in between here. And then move on. All right, using algebra with segment length. So let's read this. Draw a diagram. DE bisects AB. So you have to stop and think here for a minute. Which one is doing the bisecting and which one is being bisected? So DE bisects. That tells me that DE is doing the bisecting, and DE bisects AB. That means AB is being bisected. Okay, so I'm going to draw my line segment AB. Okay, and here comes DE. Okay, bisecting AB at point C. That's what this says. So here's point C right here. So I now know that these two segments are equal. I also know that point C is the midpoint. Okay, so if AB moving on. If AC is 8x minus 3, and CB is 4x plus 57, then those two equations have to be equal to each other. So subtracting 4x from both sides will give me 4x. Adding 3 to both sides is going to give me 60. Divide by 4, x equals 15. And then, of course, you could plug that back in here and here to find out the length of the segment. Okay, next big vocabulary word is angle bisector. Take a minute, pause the video, and write down the definition. Okay, quickly, hopefully you copied it in your notes. Angle bisector takes one big angle, so this big angle, this guy is cutting it in half. Okay, notice these markings here, just like with a line segment bisector where I can mark it when each side is equal to each other. These two lines mean they're equal. Same with angles. This and this means those angles are equal to each other. Okay, so that's really important notation and important that you understand. All right, given BD is the angle bisector of ABC, what is the measure of angle ABC? So I'm looking for the measure of the big guy. Okay, it told me that the BD is the bisector. It even shows me this here, that is the bisector. So here's the thing. If this angle is 45 and they are equal, then this angle also has to be 45 degrees, which means the big angle has to be those two added together. So the big angle is 90 degrees. Okay, EF bisects DEG. So EF is bisecting DEG, which means this angle and this angle are equal. Okay, and notice it says the diagram is not drawn to scale, so you'll see that a lot. That means it might not be proportional. Okay, so if the measure of angle DEG, so here we go, DEG, the big angle is 88. Find the measure of FEG. So I'm looking for FEG, which is this guy. Okay, well let's think about this logically though. If there's an angle bisector involved and these two are equal and the big one is 88, what do each of these have to be if they have to be equal? You're right, they are 44 each. They have to be 44 each. Okay? Problem is the same type of problem, but a little different twist to it. So we're going to do number 2 here. If the measure of angle FED, so FED is 27, and I need to find the measure of GED. So now I'm looking for the big one. Okay? Well, again, if these two angles are equal and this one is 27, then this one has to also be 27, which makes the big angle 54. Okay, so here comes the algebra. B is the angle bisector of ABC. So already I know this and I already know this. Equal angles. If the measure of angle ABX equals 5x, so ABX equals 5x, and the measure of angle XBC, so XBC is 3x plus 10. Find the measure of angle ABC. So find the measure of angle ABC. So here's the angle ABC. Okay, I have to think about this logically because they didn't give me anything for ABC. But I do know that the two little angles on the inside are equal to each other. So let's start there. I know that 5x has to be equal to 3x plus 10. All right, solving for x, if I subtract 2x from both sides, or 3x from both sides, that's going to give me 2x equals 10 and x equals 5. That means that this angle is 25. And 3x plus 10, 3 times 5 is 15, plus 10 is also 25. So if each of these is 25, then the big angle has to equal 50. Okay, so if you're not sure where to start, think about solving for x, and then it should take you into your next. If the measure of angle ABC is 4x, so ABC, the whole thing is 4x minus 12. And the measure of ABX is 24. And BX is the angle bisector. That means this angle and this angle are the same, which means this is also 24. You could find the value of x by combining these into 48 and setting them equal to 4x minus 12. And if you do the math, you will come, or 4x minus 12 equals 48, sorry. If you do the math, x will become equal to 15, I believe. Yep. And then you can find the for each angle. Okay, last one. Is 4x plus 16. BX is the angle bisector. And CBX is 3x plus 6. All right, well, if CBX is 3x plus 6 and these two are equal, that means this is also 3x plus 6. All right, so the little two angles have to, added together, have to be equal to the big one. So 3x plus 3x gives me 6x. 6 plus 6 gives me 12. Has to equal the big angle, which is 4x plus 16. All right, subtracting 4x from both sides gives me 2x. Subtracting 12 from both sides gives me 4. So x is going to be equal to 2. And then you could go ahead and plug the information in to your problem and solve for each individual angle. That's it for today's lesson. I hope you're feeling better tomorrow, and have a great evening.